Thank you for the introduction. I'll probably stay here just to see everyone because I've seen like if I stay there, I will not see half of the audience. So I'll stay here. I'm solutions architect at AWS, and before the meetup, we were discussing this a little bit. So what solution architect, how to be a solutions architect, and what solutions architect does. But as a very high-level overview, so as solutions architect, we are part of the field team, so we work with our customers. But this doesn't mean that we try to sell you something, so we are not like, we don't have any incentives on the revenue, we don't have any quotas or anything like that. And what this means is that oftentimes I work with my customers on optimizing the architecture and actually help them to decrease the amount of money that they spend on AWS. And that's why I wanted to speak about this topic today, about Gravitons. Actually, I'm disclosing right away why I'm speaking about it. But yeah, hopefully it will give you some idea how you can save money when you run EC2 instances in the cloud. And I'm sorry, Ahmed mentioned that we expect the talks in these user groups to be quite basic, and he didn't know that. So I've made it a little deeper. So if anything is unclear, you can just raise your hand and we can just stop in the middle and discuss this. So that's absolutely fine to interrupt me. But just a quick story, like who knows what ARM is? Okay, quite a lot of people ARM, so this one. Okay, cool. So yeah, then let's, as not everyone knows about ARM, let me just give a very short slide of kind of history or what ARM is. So ARM is basically a RISC architecture, so reduced instruction set computer architecture. And this architecture is different from x86 architecture that is used on most of the computers nowadays. And initially it was developed by the company ARM Limited. And basically the ARM Limited created the design of this architecture, and then there are multiple companies that create processors based on ARM architecture. And as it is lower cost and lower power consumption, initially it was really popular among embedded devices, mobiles, and so on. So I think I've heard like 90 or maybe 95% of the handheld devices of mobile phones actually use ARM architecture. But now it's getting adopted more and more. So you probably have heard about Apple releasing MacBook on M1, M2 chips. And actually, it's also used in the servers nowadays. And that's exactly the reason why I'm speaking about it today. But just a couple of words why I was so interested. So Graviton is probably the #1 topic that I speak on different conferences or different meetups. And the reason why I was interested in it is we have released the Graviton processor based on ARM architecture in 2019. And the marketing figure that was provided on our AWS website was that Graviton 2 processors provide up to 40% better price performance compared to x86 instances. I was like, stop. Okay, I understand that like my iPhone has ARM architecture, but really is it, if I run my application on a server, is it really more performant and more, well, it's cheaper, yeah, it's clear. But is it really more performant? Well, I trust our marketing team, but as an engineer in heart, I was just a bit skeptical and I wanted to test it myself. So I and my colleague, Alexander Zumov, we started doing some benchmarking, and I'll say a bit about it today because there were quite a number of stones under the water that we hit while doing this benchmarking, and I wanted to share them with you so that when you do your own benchmarking, no matter if it's ARM or something else, you don't repeat our mistakes. But yeah, let me speak a bit about Graviton. So it's all started actually in 2015 when Amazon acquired a company called Annapurna Labs. It's based in Israel. And this company is actually developing the chips. So now, this company being part of Amazon, in 2018, we have released our first own chip, so basically developed inside Amazon. It was called AWS Graviton. And it's actually available in the cloud. Like, who knows what EC2 is? Okay, most of the people. So EC2 are our virtual machines. So we call them EC2 instances. These are basically virtual machines in the cloud. So, and we have these EC2 instances called A1 available on this chip. But to be honest, I haven't seen much traction. What's changed a year later is we released Graviton 2, as I've mentioned, in 2019. And it had like 4 times more virtual CPUs with 7 times better performance overall, which means approximately 2 times better performance per vCPU. I will not go deeper into these nanometers and other stuff. It's really not a topic today. But that's when I was interested in this technology, and that's when I've seen some traction across my customers about it. So, but why we have this interaction? Well, actually, I've already disclosed it in the beginning. So first is the price. If we just compare the instances, the same size instances on, let's say, M6G, which is Graviton instance, and M5, which is based on other processor, on x86 architecture, we would see it's approximately 20% cheaper. And it's not like marketing promotion or anything like that. It's real like list price. And then the performance. And with the performance, it's actually quite interesting. The performance that you will get differs by the workload, and that's why it's super important to do the benchmarking first. And I'll again speak a bit about some of the things to consider there. But before that, I wanted to share one important difference when you work with Graviton processors or processors based overall on ARM architecture compared to, let's say, Intel or AMD or other processors on x86, is that each virtual CPU in Graviton, so in ARM, is a separate physical core. So what this means is, let's say we have an instance based on x86, and we have two vCPUs. And let's say we have some tasks in both of these vCPUs. So these tasks will get scheduled one after another on the main physical core. And if the load is not that high, that's actually great, because we save on the resources, and we kind of fill the holes with these different tasks. But let's say we have a really loaded system, so many customer requests or something like that. Then what will happen is, again, they will schedule one after another, and the execution will be, well, apparently 2 times longer. So with Gravitons, you don't have hyper-threading, you don't have multi-threading, no L1, L2 cache on the processor is shared. That's why basically each task on the vCPU just gets mapped directly to the physical core. And from this, you actually might understand why I was speaking about the different patterns and different performance gains that you might achieve with ARM architecture. So you might guess that when your system is more loaded, the performance gain that you would get is higher than when your system is not that loaded. But yeah, some benchmarks to support my words. So first I wanted to start with SPEC. SPEC is an industry benchmarking standard for virtual CPUs. We have used the version from 2017. It's several years old, but it's also quite stable. That's why we've taken it. And it has tests in C, C++, and Fortran that run on all virtual CPUs at the same time. And what they test is they test 2 areas. So there are some tests with the integer side, and that's kind of run in Perl code, compiling GCC, conversion from XML to HTML, and so on. And then there is the second side, floating point side, which is different physics simulations, ray tracing, weather forecasting, and so on. So, and as you can see on the slide, so the blue one is M5 instance based on Intel processor, and the orange one is M6G based on Graviton. So the Gravitons are about 44% faster on the integer side and about 24% faster on the floating point side. But again, that's some synthetic tests. Of course, it looks nice, but what's in it for you? You are not there to run synthetic tests. So I wanted to show you one thing, and I've chosen Nginx because that's probably something that is used by most of my customers. Nginx is a popular web server and load balancer. So what we have done is we have taken a load generator and we have used a tool called Work, it's spelled WRK, to generate the client HTTPS request. Then we had the actual web servers for them, and so this one was on the Intel C5 9x large. These ones were also on Intel C5 4x large. So the only thing we were changing is the one in the middle, the Nginx piece. So and we were changing it between Intel and Graviton processors. And again, here we have seen 24% increase in the performance. And the last thing I wanted to show you from this kind of generic slides before we actually jump to more practical stuff is that new generation. And we have just released it this year. So we announced it at the end of last year, released this year. And actually, by the way, just a side note, in the end of November, in December, we have reInvent, which is our annual conference, and there are a lot of announcements there. So if you're interested in following AWS, you might subscribe to our blogs. You might subscribe to our podcasts where we have the news. So we have podcasts in English, we have podcasts in Russian. So in November and December, you get really kind of flow of these new releases from AWS, which you might find interesting, which might address some of your use cases. But yeah, back to Gravitons. So we have released the 3rd generation of the instances. And it's the orange once again on the diagram, and you can see that the most benefit is on the floating point side. So with the previous generation, floating point didn't get that much attention or that much performance. That's why we have addressed it specifically here. And why I wanted to highlight it is if you do any kind of machine learning or high performance compute, big data, which you do on CPU, then you might want to look at Graviton 3, because that's where you would get the most performance. The only thing here is, and one more moment, is that they have DDR5 memory. That's the first instance with DDR5 in AWS. So if your application is memory bound, if you need fast memory with high throughput, then you might want to look into it as well. But one thing is that Graviton 3, as it was just released, it's only available in limited number of regions. So you might know that in AWS, not all services are released like around the globe. So they go into some regions first and then get rolled out to other regions. So Graviton 3 is not available everywhere yet, like Frankfurt and Stockholm that are often used by the customers in these regions. It's not there yet, unfortunately. But yeah, so this was data from our engineering team and from our marketing team. But it's myself standing here, not them. That's why I wanted to share a bit of what we were doing. So, and as I've mentioned, we wanted to benchmark it, and we actually started with databases, because it's quite easy to benchmark a database on different architecture. You just take the distribution for the correct architecture, you install it, you upload the same data set, and then you run the same queries. So first we started with ClickHouse. ClickHouse is an analytical database. It was initially developed in Yandex. Now it's actually a separate company. And they do have their own benchmark on their website. But there were several problems with this benchmark. Well, first is that it had the client and the server running on the same virtual machine. And as you can imagine, this can lead to some interference, because as a client we are sending the queries, but effectively we are doing the benchmark on the same server, and we already have some resources used there. Another problem that we have seen is that as it is on one server, we couldn't test any cluster configurations. And the best thing with ClickHouse is that it scales linearly. So what this means, let's say you have 1 terabyte of data. You put this on one server, and then you run some analytical queries to it. Then you add another server, and you shard this data between these two servers. So the queries will become approximately 2 times faster. And that's, so if you were working with databases, you can imagine that it's not an easy task to achieve. That's why a lot of customers actually like ClickHouse, and that's why I've selected it to be tested. Another thing with that benchmark is that it was prioritizing the warm starts, while for some of the customers it's more important to measure the cold start. And the final thing that I didn't really like is that it had Yandex Metrica as its data set. And I'm not saying that it is biased or anything like that, but you know, when you benchmark, it's always better to take data set not from the vendor, but some other data set. So what we have done, we have tested it first of all with 2 data sets, both the Yandex Metrica from the vendor as well as New York City Taxi, which is kind of standard data set for analytical workloads. Then we have tested both cold and warm runs. And of course, we have moved client away. And the final thing is that we have also set up 4 cluster configurations. So initially in 2020, those were just parallel replicas. This year, we have repeated this test, and we have also tried with shards. So what we achieved? We have seen that on Yandex Metrica dataset, Gravitons are about 20 to 40% faster than the instances on x86 of the same size. So, yeah, quite good statistics. Worked with customers on that, but of course we're interested to test further. So we have selected MongoDB after that. At that time, it was still version 4.4, so MongoDB is NoSQL database. That's why we have taken YCSB. It's Yahoo Cloud Serving Benchmark, which is kind of standard benchmark for NoSQL workloads. So we started testing this, and we have found that both Intel and Graviton give approximately the same results. Well, I was quite disappointed with that because like Yandex Metrica was first, and I also expected like 50% performance gain. So we started digging to understand what is actually happening there, so why the result is not that great as we were hoping for. So we have worked with Graviton development team, so the people who actually created these processes, and we have found a couple of things, and they're important because that also shows what you need to do when you migrate to ARM. So the first thing is that MongoDB 4.4 at that time, as I said, it was the latest, but there was version 5 being in development at that point of time, and version 5 had some improvements in the support of ARM architecture. So overall, as you will see later in my presentation, it's quite easy to migrate between the architectures. But if you have any kind of processor level optimizations, and the things like MongoDB do have them, then when you migrate, it might lose some performance unless you introduce the same optimizations for ARM as well. And ARM has different assembly than x86. That's why it will not work like right away. So that's one thing. The second thing that we have found is that YCSB with the default settings, and we have used more or less default settings, we just customized them a bit, didn't load the system enough. And what I've mentioned in the beginning, the load pattern is super important. So when we loaded it more, that's when we have seen the benefits of the Graviton. But with like middle load, it was like 1-to-1. We still, of course, got this 20% cost reduction, but you can see that the performance gain is not something we got. And by the way, one thing I forgot to mention, now I see New York City Taxi. So with the Yandex metric, I've said that we had 20 to 40% performance gain. With New York City Taxi, we had actually less. With New York City Taxi, we had 5 to 50% performance gain. So yeah, 50 is more than 40, obviously, but 5 was too little. And again, we started thinking, what happened? So why we got only 5% performance gain? So we had quite advanced monitoring set up with Graphite. And we have found that actually we were getting to the constraints of our disk, of our EBS disk attached to the virtual machine. So New York City, the Taxi data set was so large that actually instead of measuring the CPU performance, we were measuring the disk read speed. And obviously the disks were the same between both instances. That's why we didn't see the difference. So that's another thing I want you to take out from the session. So when you do the benchmarking, make sure you have the monitoring to know that you're actually benchmarking the thing that you think you're benchmarking. And finally, after that, I was doing like a couple of personal projects on ARM, and I worked with my customers for migrating the applications. So these were the ones on Golang, Java, and Python. Of course, those are not the only languages supported by ARM, but these are the ones that I personally worked with. And this is the slide where I wanted to show some data from my tests with my colleague Alex. So here you can see the first one is C5. It's now already the previous generation of Intel. Then we have C6A, that's AMD, the latest generation of AMD. And actually that was a request we received from customers quite often, that can you also benchmark AMD? Then we have C6I, the yellow one is the latest generation of Intel. And then we have Graviton 2 and Graviton 3. So on this diagram, the smaller the bar is, the better. So a couple of things I've taken out from this test. So first, if you look at Intel of the 5th generation and AMD of the 6th generation, you can see that they are approximately the same. And for me, to be honest, this was quite eye-opening. So I didn't realize that actually, if you can't migrate to ARM architecture, if you want to stay with x86, but you want to save some money, what you might consider is actually moving to AMD. And you would get approximately the same performance, well, a bit less, but still, like, maybe for you the costs are more important. So that's one thing. Another thing that we can see here is that Graviton 3 is about 29% better than Graviton 2. And that's actually even better than the marketing figure of 25% that I provided a couple of slides ago. And the last thing is that because we were showing the results at that time of C6G and C5 to customers, they were asking, well, yeah, that's great to compare it to C5, but like a month ago you have released C6i, the newest generation of Intel. Is Graviton 2 still better? And as we can see here, yes, it's still faster, even compared to the latest generation of Intel. So I mean previous generation of Graviton compared to current generation of Intel. So now, a couple of practical advice. So what to do if you do want to migrate or if you want to start a new application on Graviton. So first, I would recommend to look into the workloads. And let's say, even if you are developing a new application, it still contains different parts inside of it. So I would recommend to start some parts first if you want to try Graviton. And the very first one that I would recommend to look into, which requires virtually no effort to migrate, are the managed databases, like relational databases like Amazon RDS, or non-relational ones, or my favorite one, DocumentDB, which has MongoDB compatibility interface, and others. So there, you just need to upgrade to the latest version, and you switch the architecture. That's pretty much it. Then if you use EMR, and we were discussing it today a bit with some of you, so the EMR is our analytics solution, then again, it's quite easy. Typically, you would just change the instance and it would work. The only thing you need to take into account is if you use libraries like Python libraries or Java native interface, they might be actually in C++ and compiled for some architecture, so you would need to recompile them or find the right distribution. Then we have AWS Lambda. It's our serverless function. So if you don't know about Lambda, come to my session tomorrow where I will be speaking about serverless, and it would actually be the introduction session, not deep dive like today. So with Lambda, we have some runtimes that are available out of the box, and for them it will just work. So you just need to configure a Lambda function to use ARM architecture. If you brought your own runtime, because like in Lambda, you can run pretty much anything. You can run C++ in Lambda. So if you brought your own runtime, then you will need to take care of moving it to Graviton. If we go further, it would be now virtual machines, if you run your application inside virtual machines. So if it's Linux and if you use some interpreted language or just-in-time compiled language like Java, PHP, Node.js, Python, and so on, again, it should work. So you just take the virtual machine of the right type. So because as you've seen on the previous slides, they have the different names. So instead of, let's say, C6i, you would take C6G. So all Graviton instances have this G letter in the naming. And then you just install the right interpreter and it works. Again, take care of the libraries. Then if you have compiled language like C, C++, Golang, and so on, then of course, except for that, you would need to recompile your application. Then if you use .NET, well, it becomes quite some work because then you would need to migrate to .NET Core and to Linux. And that's when you can use ARM architecture. And if you use other applications on Microsoft Windows Server, so not .NET, unfortunately, that's not something that can be done right now because this operating system doesn't support ARM yet. So now, what I would say is the best approach is that, first of all, you define the testing approach, so how you verify the results, because like if it's new application, okay, that's great, we can build it directly on ARM architecture. But if it's an existing application, we need to understand like if it makes sense to migrate it or the price or performance benefit that we will gain is not enough. So define the testing approach. Look into your development tooling, like your CI/CD tools, or maybe some code review, anything else that you have, if it supports ARM architecture. And then, as I've said, start with managed services, go to development test workloads, and then to new applications. After that, you can you will already get some experience with Graviton. You will get some quick wins. That's probably when you can explain to your managers why Graviton is cool and why you are spending time for that, and then migrate the existing applications, like first the scripted and then the compiled ones. Now, how do we start? So there is an ideal plan. I'll start with it because that's kind of best practice from AWS, how you do the migration. So the ideal plan is that first you create a catalog of all your libraries, your agents, and so on. And here I mean like agents, for example, monitoring, logging, security, and yeah, pretty much anything else. And overall, it's a good practice to have the inventory. The only problem here is that it can become quite complicated task, especially if you use something like Node.js with lots of like really long dependency tree. But overall, a good idea to have it. And then you check if there is ARM support for it. So if there is ARM support, or if maybe the agent or the library is platform agnostic, just go ahead and use it. If not, check the roadmap. Because many tools, if they don't support ARM yet, they plan to have it in future. And with my customers, like as I've said, I was doing that benchmark after 2019 release, so it was pretty much 2020. And I was speaking to some customers, just showing them the results. And from most of them, I've heard, yeah, it's great, but we don't see much support for ARM architecture in the ecosystem. And I would say maybe like 99% of the customers that I was speaking to were waiting for Apple to release MacBooks on the ARM architecture to go ahead and migrate to Graviton, because that's when the ecosystem will support it. So when they see that Apple is supporting this, yes, we can go there. And now it's like 2 years since Apple released these computers, and I would say that the support across the ecosystem is really widespread. So even if there is no such build for your tool, probably it's on the roadmap. And if you don't see it anyway in the roadmap, if community cannot help it, you can also reach out to us. So you can reach out to the user group, or you can reach out to your solutions architect, because effectively any customer, and you're all, if you have an AWS account, you're all customers, you have a solutions architect. So probably you don't know about the solution architect. It can be a person like Igor who is responsible for the whole area. So, but if you use Contact Us button, in the end of the day, it will reach Igor's inbox, and he will be able to help you. You will?
Yeah.
All right. So now the next step is testing and deploying. Well, sounds simple. So testing, of course, that's super important. And here I mean like all the tests end to end, starting from unit tests, integration tests, acceptance tests, and of course performance tests. And in the end of my presentation, I'll share one story from my customer, how we were migrating to ARM architecture, and you will see why it's important. But really, like, there are still some kind of things that happen, because during all the years of x86 architecture, there were a lot of optimizations there, and it might happen that your very specific use case works differently on ARM, even though it shouldn't be the case. Everything happens. As our CTO Werner Vogel says, everything fails all the time, so you need to be prepared to that. And even more important, if you do compiled applications, test it. Then update infrastructure as code, and I do hope if you run anything in AWS in production, you use infrastructure as code. If you don't, please start doing this. So infrastructure as code is things like CloudFormation, CDK, or Terraform, where you can just describe your infrastructure as a text and then roll it out to the corresponding system and easily create the development environments. And then, of course, you can or should store it in Git, and this way you also have the history of all the changes to infrastructure. So in your infrastructure as code, you need to update the image of your virtual machine. In AWS, we call it AMI, Amazon Machine Image. Update the instance type to one of Graviton ones, and maybe user data. So user data is the script that is executed when your virtual machine is first booted. And if you have any hard code of the architecture, you will need to change it. And then the deployment itself, so I would recommend to use either green-blue deployment or canary deployment, definitely not like Big Ben, directly move to Graviton. And make sure you monitor the metrics after that. And as you probably know, technical metrics do not always provide us the whole visibility into the system. So it can happen that all technical metrics show everything is fine, but the users are getting some problems. So what I would recommend is to also monitor some business metrics, maybe the number of orders, number of new signups, and so on. But yeah, that was the original, the ideal plan. So now let's go to reality and see what works, at least with my customers. Start with managed services. So it's still the case, even in reality. That's a good advice, and that's what I've seen also works when the initiative to change comes from the bottom up. So let's say you as engineers, maybe you will be interested in Graviton, and you will speak to your manager and say, hey, let's migrate to Graviton. But then the manager asks you, okay, how much efforts will it take? And you start calculating, and then the manager says, well, I'm not sure if you should invest the time in doing this. So if you start with managed services, like migrate, for example, your database to Graviton, then you can just come to your manager, show here are the results, here are the benefits that we are going to get. So can I go ahead and spend my time doing this migration? The next thing is try it on one service. So I was speaking about creating inventory of everything. Well, in fact, it's better to just try and see if it works for you. First of all, I would recommend to do the benchmarking of one service. Just take it without any CI/CD or all this stuff. Just take it, manually build it for Graviton, for ARM architecture. Try to run it, do at least basic performance test and see. So maybe if you see the same results, maybe it would not be worth it to actually do the migration. But if you see great results, that's when you can understand, yeah, let's invest time and let's go the whole process. And again, infrastructure as code here would really be helpful. So in the initial test of 2019-2020, we were doing everything manually. So bringing the virtual machines down, changing the configuration, bringing them up, and so on. And it was taking a lot of time. So now in April and May, when we were doing this test once again, we used CDK, and it was great. So for me, it was super cool. I just like click a button, and I get the tables like I've been shown on the previous slide with the latest configuration. So. And another thing here, as I've mentioned, like just build it manually. So even if your agents do not support ARM architecture yet, so just test it before you reach out to community, before you spend your resources, see if it's worth it. And another thing, don't boil the ocean. Don't try to prepare to everything in advance. So what has worked best across my customers is trial and error. So we take our application, we compile it to the ARM architecture. Oops, something hasn't compiled. Let's fix the issue. Let's go ahead and compile once again. Let's start it. Oops, some integration doesn't work. Let's again fix it, and so on. So this kind of trial and error process, of course, it takes some time, but it's easier than trying to think about all the possible scenarios in advance. And finally, after you get this experience, after you play around on one service, on limited number of services, that's when you can look into the whole chain. And one more thing I wanted to mention here is about naming. So you probably know AMD 64 and x86 64. So some of the software packages, or like packages operating systems, like BSD, many Linux distributions, Docker, use the abbreviation AMD 64 to call this architecture. Some, like other Linux kernel itself, GCC, and some other Linux distributions, call it x86 64. And it's actually the same with with ARM architecture. So it has two names. One is ARC64, which is used by GCC. Another one is ARM64, which is used by Linux kernel and some others. And I also got caught into this once when I was just starting working with Gravitons. I wanted to benchmark one tool. So I went to the repository and started looking for the package for ARM64 because I've seen like this name ARM64 in my Linux kernel. And there was none. I was like, oh, probably it doesn't support ARM. And then I've seen this strange ARC64. I was like, oh, is it probably the same? And that's when I found about this difference. So I just wanted to mention it to you so that you don't get caught to the same problem. And a couple of slides, I wanted to speak about containers. So with containers, we, of course, have different layers. So we have already discussed the hypervisor level, which is like different instances, which depends on the architecture. Then the image, also as I've mentioned, depends on the architecture. So you would get this image either from AWS, so you build yourself, and depending on that, you either select a different image from AWS or you rebuild it. Then you have your container base image, which comes maybe from Docker Hub or or just you build your own one. Then this is something that you will definitely need to take care of yourself. So find the correct base image and change it. And for the application piece, it's something that differs as we were discussing in the previous slides. And that's how it looks like. For example, on Docker Hub, here in the bottom left corner, you have the architecture selector. So you can just filter by it. And as you can see here, I filtered for ARM64. And by the way, there is ARM 32-bit, but not in AWS. So filtered by ARM64, and as you can see, there are several 100,000 results. So quite a number of them that you can select from. And one more thing with containers that you might think about is multi-arc images. So what Docker supports are basically container images that are available for both x86 and ARM architecture. So in the end of the day, what you're doing is you're creating a manifest list that points into two different images. But with this manifest list, and I have here in the bottom the comments how you can do this. So with this manifest list, you can work like a regular image. Like, for example, let's say you have Kubernetes, where you roll out your containers. Instead of, in your pod, in your container, instead of putting the name of the regular container image, you can put the name of this manifest list. And then the Kubernetes itself will decide, OK, this virtual machine is ARM64 based. That's why I will take the ARM64 container. This one is x86 64, so I will take a different one. So you don't need to take care of that. But on the other hand, why do you need this complexity? So let's say if you decide to migrate to Graviton, why not just migrate? Why build these complex multi-arc things? So the answer, as is almost always the case with the technical things, is it depends. So on the one hand, multi-architecture is a big bang, especially if you have like large project used by hundreds of thousands or maybe millions of users. You don't want to just take it and move directly to a different architecture. So probably you would use some canary deployment approach and just gradually switch the traffic, and that's why you would need your multi-arc containers. But on the other hand, that's definitely more efforts to do the maintenance. And yeah, from my experience, more customers actually migrate directly because they just migrate, they start with a specific microservice that is not that much used, just to avoid the impact, and then migrate the rest. But I have some customers who use multi-architecture as well, so you might want to consider this. And in case you haven't seen, this is how the manifest looks like. So in Docker, there is the command docker manifest inspect, and that's where you pass the name of this manifest, and you can see that it basically points to two different images in Docker with different architecture, well, but the same operating system. And this is a graphical representation of that. So you see that we have manifest on the left. It has kind of links to different operating systems, different architectures. And on the right-hand side, you have your regular Docker image where you have all the layers and all the additional configuration of it. And finally, as I've mentioned, Kubernetes, just one quick note on it. So as I've said, on Kubernetes, it should work out of the box. You don't need to change anything. The only thing, if you want to control yourself how your containers get distributed, then you might want to use node affinity or node selector. And there is a key which is called kubernetes.io/arg, which actually points to either AMD64 or ARM64. And that's where you can select it. And one last section before we get to the final tips and tricks that I wanted to share with you is CI/CD. So a couple of approaches. Sorry, before I get to the couple of approaches. First, even when you have CI/CD, even when you have everything automated, you would want to start with managed services. And as I've said, so first you verify the prerequisites. And normally that's just the latest version. So like, for example, if you use MySQL on RDS, not all of the versions support ARM architecture. So you need to check in the documentation on the AWS website which one does. And just if you're not there, upgrade and then migrate. But consider the process as well. Because like for some services, it's the switch is like instant and you don't need to do anything. So you just update your infrastructure as code template, you apply it, so you run it, you deploy it in your CI/CD pipeline, and you get your application migrated. Well, for some other services, and I think RDS is one of them, but if you do this check in the documentation, leads to downtime. So what this means is that if you just change the instance type and if your database is just one single availability zone, doesn't have any replicas, then what would happen is this instance will go down, the instance type will be changed, and then it will go up. So it will take some time, which you probably don't want to have in production. So just look into the documentation to see the process, and maybe if it's downtime related, consider having some replica to have this failover and avoid the downtime. And for non-containerized applications, we have already discussed it, quite easy. So just check if it works first, and then add ARM runner into your CI/CD pipeline and let it run. Now, what we do with the containers? So with the containers, we actually have a couple of approaches. First, you can do the native build. That's the same as for the regular application. So depending on your CI/CD system, it would be called runner in GitLab, agent, I think in Jenkins, whatever else it's called in your system. So add ARM runner and build separately for each architecture. But another option, you might want to say, well, I don't really want to have ARM runners in my CI/CD system because it's just one microservice. I don't want to spend these resources staying there for one microservice. So what you might want to do is to do a cross-compilation. So it's the thing that is provided natively by, for example, GCC and other compilers. So what it allows you to do is it allows to build a binary for ARM architecture on x86 architecture. And that works actually nicely, but the problem here is if you have any additional libraries that are in your system, they might already have a build process in place, all these make files and so on. And to move them to use cross-compilation would be more efforts than actually doing a native build. So look into your application, and actually another thing is testing, because you probably want, before you do the deployment, you want to test, and how do you test if you don't have ARM instance? So cross-compilation can be good in some scenarios, but I would say probably not for just generic use case. And finally, emulation. And if you look for instructions, even on the GitLab website, by the way, of building for Graviton, you would see that they recommend to do the emulation. Emulation is basically docker build x command. And it uses QEMU. QEMU is CPU emulation. So, and it's actually, again, it's nice for testing. Like, let's say you as developer just have your laptop, whatever it is, like ARM architecture, x86 architecture. You want to build on a different architecture. You run docker build x, everything fine. But the problem is this is emulation. It's 3 to 6 times slower compared to native build. So I wouldn't recommend to do this in production just because your builds will become slower. And probably you see where I'm going. I would definitely recommend native build to be your default option unless you have some concerns with it. And as I've said, probably the cost concern would be the main one. But again, like for example, most of the CI/CD tools out there, including GitLab, including Jenkins, including TeamCity, they have some kind of integration to auto-scaling groups. And like if cost is your concern, then what you might want to have is just to scale down to 0 runners when you don't have any ARM builds, and then scale up when you have a build in the pipeline, and then not spend anything additional on the cost. And that's how this native build process looks like. So you have basically two instances. In one of them, you build the x86 architecture and test it as well. In another one, you do this for ARM architecture. And then, as I've mentioned, you need to build this manifest list if you want it to be deployed to any node. And you can do this on any instance. So, like, for example, if you use GitLab, you might want to tag the first two stages to be running on these specific instance types and not tag the latest one so it runs on whatever is available. If you have a choice, I would recommend to do the last step on ARM architecture just because it's cheaper. And then you deploy with whatever process was there in place. So let's summarize some things that I was saying in the presentation and some that I didn't have time to cover, and we'll do this now. So start with low-hanging fruits, so managed services and open source, like open source databases. So this way you would get cost optimization in place, which would help you to show to your managers why are you doing this at all. So and of course it will also get you the experience needed to work with ARM architecture. So then use infrastructure as code. As I've said, both good for your main application migration as well for your benchmarking to make it faster and not spend time just rebuilding the environment. Verify the performance on your data and on your load patterns. So again, remember my example with ClickHouse and New York City dataset and with MongoDB and lower load pattern. And make sure you benchmark the right resource. Again, my story about benchmarking the disk instead of CPU. So use the latest interpreter and compilator version. So as I've mentioned, like for MongoDB it makes sense, but here it's, well, for MongoDB it makes sense actually not just for interpreter and compilation, but pretty much anything. But interpreter and compilator are especially important. Like for example, my customer, I've mentioned one of my customers, they're using Golang. And I don't remember the exact version, but the one that was released this spring. So they have migrated to it, to the latest Golang version, and they have the application already in Graviton, and they have received quite significant performance gains. So I can't disclose it right now, but it was faster than it used to be. So just make sure you use the latest version. One thing I can disclose is, like, for example, PHP with the version 7.4 as compared to version 7.3, it's like 30% more performant on ARM architecture. Make sure you have all source code. It sounds obvious, but it's the case. Actually, it's also my customer, and we were speaking with them on High Load conference. And we have shared the story. So they were doing the migration of the application, and they have migrated almost everything when they found that they don't have a source code of one component, basically just the binary. And it was almost a blocker for the whole project. And well, it was really disappointing. In the end of the day, the resolution was quite simple. They found it in one of the backups. But yeah, just I think, especially in larger companies, it might happen that you don't have source code, and everyone who was working on this component already left the company. So just check if you have it before you do your migration. And as I've said, check the regional availability, especially for Graviton 3, but Graviton 2 is also not in all the regions yet. So check if it's in the region where you want to run it. Don't forget about dependencies and libraries. Well, again, quite self-explaining. So they might be compiled for one specific architecture. Don't use emulation when building, and what I wanted to say here, when building for production. So on your laptop, you can do this. And the final thing is don't migrate production before testing. Again, sounds obvious, but even if it's an open source tool, don't do this. And here I wanted to quickly share, I see I have just 5 minutes left, so quickly share a story of my customer. It's actually the same customer as in the last story. So when they migrated the application to Graviton, they had it running in an autoscaling group. It's quite large autoscaling group, quite many instances. What they've noticed is that from these instances, approximately once a day, one instance just gets kernel crash. Well, it's not the biggest problem because it's autoscaling group, so it just brings up another instance instead. So it doesn't affect the customers, but it doesn't seem correct that the instances have these kernel crashes. So we started investigating it. First, they were investigating themselves. Then they have involved myself. We have involved some principal engineers from our support team, our service team. In the end of the day, we have even involved the ARM Limited to help us troubleshoot this issue. So it was not the easiest one to catch. I think we've spent something like a couple of months trying to reproduce it. And the problem was that we couldn't find any use case how to reproduce it. So it was reproduced in production, but not on the test set. So in the end of the day, what we have found is that it was a bug in Linux kernel in the way how it processed equals, and it was actually a bug both for x86 and for ARM architecture. Just because of some specifics of ARM architecture, it was occurring there more often, and those kernel crashes that were on x86, they just went unnoticed. So our Graviton team, so the people who developed this processor, sent the patch to Linux kernel distribution list, so we made the world a bit better, but that's just, I wanted to show you why testing is so important. And yeah, of course, the last thing, don't switch all the traffic without monitoring. So as I've said, make sure you understand what happens in production. Again, probably if this customer didn't have monitoring in place, they wouldn't even notice that something was going wrong. So that's why it's so important. And in the end of my talks, I usually like to provide a lot of links where you can get some information about the topic. But here, honestly, I decided to put just two of them, my favorite ones. So on the left-hand side, you have this GitHub link to AWS Graviton Getting Started. For me, it's like really #1 resource if you're interested in Graviton topic. So it's maintained by, as I've said, the same people who created the processor. So these are the ones with the most knowledge on it. And they have some best practices, some instructions on migrating for different programming languages, for different software, for different stacks. They have some instructions there on how to do the benchmark. And very important, as oftentimes you go to GitHub, you find some repository and it's never maintained. This one is maintained and it gets new information quite often. So I would recommend to look at that one. And then on the right-hand side, we have Graviton 2 workshops. So workshops are basically just a set of instructions. Like if you're interested in how to use Graviton with containers, like our service CCS, or the EKS, the Kubernetes, RDS, the relational database, OpenSearch, which is our distribution of Elasticsearch, EMR, and so on. So you can take a look there. And actually, these workshops is something that we also do in kind of one-to-many environments like this user group. So if you find this workshop interesting, or if you find any workshop interesting, actually, we can work with Ahmed and just organize a workshop for you. So what this means is that, let's say, next time, either myself or Igor or other solutions architects from AWS can come here. So we will provide you a special code. You will enter this code on the web page, and you get an access to AWS account, pretty much unlimited access for, let's say, 4 hours. And then we will just discuss some topic like Gravitons, and you would be able to go ahead and just log into that account and play with it yourself in this real environment. So if this is something interesting to you, speak to Ahmed, and we can definitely organize this. And with that, thank you very much. So if you have any questions, I can answer to them now. If you're shy, if you don't want to ask it publicly, feel free to reach out on LinkedIn. Thank you.
So,
question? Go ahead.
I understand that Graviton is cheap enough for right now, but can you use the same patterns for even further saving, like spotting instances or reserving instances with Graviton?
Yep.
Do they support?
Yeah, absolutely. So yes, they do support. So Graviton supports both spot instances and reserved instances and savings plans. So all of these things are supported. Just one thing. So when I was saying 20% price reduction, that's for on-demand price. So for spot, of course, it can be different. It can be high. It can be lower. I don't know, to be honest. So you need to check it. But yeah, definitely supported. And one thing here, actually, I think it was High Load where I received this question. It was like, yeah, it's 20% cheaper, but is it maybe some marketing promotion and you guys will increase the price next year? Of course, I can't comment about any kind of price increases or price changes that might happen. So far in AWS, we were just decreasing the prices more than 100 times since our inception. But I would say the point here is that basically this is the list price, and the reason for it is that ARM architecture consumes much less power. And if we look at the data center, like cost of ownership, power is one of the main components of it. And that's why it's really a sustainable thing. It's not like marketing promotion, go to Graviton. And we don't have any plans to like move all customers to Graviton, so we absolutely plan to support all the architectures out there.
Thank you.
Thank you.
All right, so during the, like after the previous talk, we missed the Q&A session. Feel free to also ask questions about the previous talk as well. And we also have 2 teachers, 2 lucky ones, who will be asking good questions, so we'll be giving them out a pretty good t-shirt.
I have a question.
Yes, please.
How we can become a AWS developer?
So yeah, just reach out to me, and we'll be. I think we'll definitely be able to. For example, I am a user. I am a part of the Center for Google Communication with this, and we are making user videos. I can make user videos, for example, in mistake for our local friends. Sweet. I think this is a pretty good opportunity. Thank you a lot, and please reach out to us. And I think we will discuss it better. Thank you. All right. Yes, please.
I'd like to actually know the environmental impact of RM64.
That's actually the great question. So no,
sure.
Honestly, like that's definitely an important topic. And as I've said, like for us in Amazon, we have this targets to reach the carbon neutral before the Paris Agreement. So yes, ARM architecture is definitely more environment friendly and more sustainable as compared to x86. And one of the main reasons there is that well, first of all, it consumes less power, as I've said. So I don't remember the number right now exactly. Is it still recorded? Okay. I will not do any guesses then. So it's just a lower power consumption. That's one thing. Another thing is that it requires less cooling, so it doesn't get that hot. So what this means is that we can put more ARM-based servers in the data center in less space of the data center. So again, we don't need to build to extend out the data centers. So I would say because of this kind of 2 or 3 reasons, that's definitely something that is better for the environment.
My actual question is, will there be any granularity in code build and CI/CD related tools supporting more types of compute for IRM? Because currently there are 2, right?
To be honest, I don't know about code build, so I would say if you can reach out to me on LinkedIn with this question, I can take a look, but I'm not sure right now. Sorry. No worries.
Thank you.
Thank you.
All right. Any other questions? Yes.
How is the AWS important for the software engineer? For example, in these days I didn't use AWS to work. And could you explain how is the AWS important for the software engineer?
Igor, you had the experience as a software engineer. Go ahead.
Yeah, so actually, do you know how... okay. Thank you very much. So do you know how you run your code in production? For example, you build, so you are a developer, right? You're a developer and you are backend developer or front-end developer? Okay, front-end. And how you build your front-end and deliver to your customers?
To be honest, I don't do that because it's delivered by my manager.
Okay. So initially we built tooling to deliver code base, what you write, for example, to build the application and deliver to the customers around the globe, right? And in this case, AWS build the network which are closely to the customers. Because of that, we are trying to deliver outpost to Kazakhstan to help them to build the AWS based on AWS services seamlessly with the region and use the same API there. And when you build your application, so this application moved to the server, and after the customers reach your website, they get your application which you built. And the good point to understand how it works, and if when you are growing as a developer, next time maybe you will go with the deployment and continuous delivery of your code for your customer. Maybe you want to build your startup, right? So currently you have manager. After when you are starting entrepreneur, so you don't have manager. You will be the person who are building code and deliver to the customers, right? And get a lot of money from that. And you need to understand how do that from your perspective as a developer and do it cheaper, for example, using Gravitons. Because you think that customers pay money for you, but you are just need to buy the servers, right, for your application, and you need to think how do it in the cheapest way. And this is help you to optimize your code and to understand how performant it is and how money your customers can't or you will be spent on the infrastructure.
All right. Yes. Can I
Just a second.
Я бы хотел спросить, например, есть, как вы сказали, ARM и x86, там разные инструкции, CISC и RISC. Вот в CISC есть те программы, которые еще не оптимизированы под ARM. Как будет, CISC потянется к RISC или же наоборот, ARM под CISC? Просто ну вот это всегда меня мучается.
Да, на самом деле, если честно, я вот буквально вчера слышал один подкаст на эту тему. Ну, то есть у меня, если честно, мнения на эту тему нет. Я не знаю, как будет. Я вчера буквально слышал, точнее, не вчера, как дни летят-то, когда мы с тобой сюда прилетели? В среду. В среду я слушал подкаст, и как раз коллеги там обсуждали именно ARM-архитектуру, и они считают, что все-таки RISC-архитектура в каком-то плане лучше. То есть, да, там некоторые части делать сложнее, потому что, в ней нет вот такого набора инструкций, потому что там фиксированный размер, но все-таки благодаря этому она, во-первых, то есть, более такая читаемая, потому что, она вот, понятно, графиком такая упрощенная, назовем, собственно, reduced, так и называется, вот, и все-таки коллеги, вот, например, их мнение, что RISC, она, в каком-то плане более такая передовая, чем CISC, и стоит ее использовать. Вот, честно, я не знаю, я не очень много работал на таком уровне, на уровне assembly, поэтому скорее не смогу ответить на этот вопрос.
Все понятно.
All right. Yes, please.
Alright, I want to touch a cybersecurity part, and I want to ask how to make our cloud services safe, how to avoid cybersecurity attacks, for example, a lot of requests, DDoS attack, and how AWS services can help us to make our database protected.
Well, at what time is the conference starting? Can we just start answering now until the morning? No, honestly, that's a great question. It's very broad, and probably we might want to do a meetup on this topic. To answer on the very high level, so first of all, what you have in the cloud is the shared responsibility model, so similar to shared user groups model that Igor has shown, where AWS is responsible for the infrastructure of the cloud, and you as the customer are responsible for the infrastructure of your workloads inside the cloud. We still have some tools to assist you with this piece as well, but that's kind of the basic separation. So one thing that you can do is that the level of AWS responsibility shifts higher and higher the most managed service you use. Like, for example, if you take EC2 instance, AWS is only responsible up to hypervisor level, and then starting from operating system, your application, your network configuration, and so on, you're responsible for that. And let's say you're running Postgres database, so you would be responsible for all these things. If you take, let's say, RDS, then you're only responsible for the schema, for the optimization of your queries, and so on. And AWS is responsible for all the patching, security things, and so on, just up to database application level. The same goes, by the way, with serverless, and there is one interesting thing. So I will just discuss it a bit more tomorrow on the conference, but CTO of one of my customers was on a conference, and then we had a meeting with him, and he was like, he had such an idea, like, I want to move to serverless right away, like, because I've heard on this conference people were moving to serverless, like, I don't remember, I think like 2, 3, 4, 5 years ago, and they had zero maintenance, zero security patches, and zero vulnerabilities, because in serverless it's all handled for you by AWS. So that's one thing, you can move to managed service. Then another thing is that we have the whole set of security-specific services, and you can find them on AWS website. I would mention something aws.amazon.com/security. So they cover at least 4 or 5 areas. So there are some services that we provide that detect let's make a step back. Some services that we provide that look into the configuration of your environment and tell you possible issues with this configuration. Then the next thing that we have are the set of services that detect the intrusion. Like, for example, my favorite one is Guard Duty, which is machine learning-based service. You just enable it and it works. So you don't need to do anything else, and it sends you some notification if something goes wrong, like maybe someone's trying to brute force you, or it seems like your EC2 instances are mining Bitcoin or whatever else. So then there are services that help with the investigation of the already occurred issues. Let's say there was something that happened, and you need to now to understand what was the vulnerability that person used in which of your applications it is, and so on. So we have services for this. And finally, if this question is coming more from compliance side, like maybe PCI DSS compliance, ISO 26001 or something else, then we have some services on that front as well that ease your communication with audit teams. So that's kind of the approaches that we have, and of course we have a lot of white papers. So there is a place on AWS website. It's aws.amazon.com/architecture. It's Architecture Central, and it has a lot of white papers, solutions, case studies. And the thing with them is that AWS services are quite broad, so they cover a generic use case for many customers, while solutions address one specific use case, and we have like specific security solutions available there, or specific security white papers. So I know that's a very high-level answer, but really honestly, if you want to go deeper, I would say that will probably take several hours. But on the high level, so shared responsibility model is how it works. If you want to increase AWS responsibility, go with managed services. If you want AWS to help you with your side of shared responsibility model, look into these 4 areas of security services. And if you want to learn more, go to the security portal and to Architecture Center.
Gotcha. Thank you, Mike.
Thank you.
Well, I think we can take one more question. Right? Please, just a second. Yeah.
Is there any problem with this AWS Graviton with other integration with other services? I mean EKS or ECS container services, because they use the EC2 instance basically, so there is no problem with that?
Not that I know of. No, there shouldn't be. So not all AWS services support Gravitons yet. For example, the DocumentDB, the one I said, my favorite, or actually does it support already?
Not sure.
Okay, so maybe not all the services support Gravitons as the instances to run on, but ECS, EKS definitely do support it. So they support both like single configuration, you can do Graviton only. They support mixed configuration, where some nodes are coming on one and some on the another. And the Fargate, which is our way to run containers in serverless manner, it supports Gravitons as well.
Kubernetes services and Kubernetes can work on this.
Yes, Kubernetes itself does work, and then with the containers, it's up to containers. I was showing, like, if the application inside container doesn't support it, well, it will not run. But Kubernetes itself, yes.
Okay. Thank you.
Thank you.
Okay. Well, I think that's probably it for the Q&A part. Mike.
Can I have my one to show to the person who reminded me of environment? I'm still in love with this comment about environment.
All right, yes. And we actually have another one. Can you please pick?
Igor.
Me? For me, person who wants to contribute.
That's a good one. All right. We have.
Yeah, so thank you very much to coming here. It's our first meetup. And if you have questions, to join our Telegram chat and ask questions there, connect, talk, share ideas, share your experience, and it will be great. And join core team if you have any ideas how can be improve the experience and education program inside Tashkent. So thank you.
Thank you.
So tomorrow we are having another conference. So that's the Rolling Scopes conference, and please come to see us. And Mike with Igor will also be there.